Alright, in this next video we're going to be doing function arithmetic, but we're not going to be evaluating it at a certain value like we did previously. Now we're going to be just finding the general equation of adding, subtracting, multiplying, dividing types of things with these different functions. So this first example says if g of x equals 2x squared plus 3x minus 1 and h of x equals x squared minus 5x plus 7 and k of x equals x plus 6, find the following. So now we're not plugging in a value. Before we would do just g of a value plus h of a value and then get the final answer as just a single number. But now we're leaving the variable as x. We're not actually going to be evaluating it. We're just getting a general formula so that we're not re-evaluating each time. We're getting a simplified function, and then if we wanted to later we could evaluate it, and it would be faster than doing these separately each time. So all we're doing really is adding and subtracting polynomials on this first example. Remember that g plus h of x is the same thing as g of x plus h of x, right? It's just adding function g to function h. Well, what does function g equal? Function g is all of this, 2x squared plus 3x minus 1 plus h of x is this whole quantity, x squared minus 5x plus 7. So you see we're just adding this polynomial to that polynomial. And we can only add like terms to like terms. So I can add my x squareds together. 2x squared plus 1x squared would be 3x squared. I can add my x terms, 3x and a negative 5x. So 3 plus a negative 5 would be negative 2x. Now when I add these, it does not become x squared, right? When I'm adding apples to apples, it stays apples. It doesn't become squared or cubed or anything like that. When you're adding like terms, that variable stays the same. Lastly, I can add my constants. So negative 1 plus 7 would give me a positive 6. And overall, that's the final answer, because that's all I can do. So g plus h of x equals all of this. I cannot simplify it any further. I will not get a single number because I don't have a point to evaluate it at. Let's look at h minus k of x. So now I'm subtracting, and you have to be very careful to make sure you subtract everything. So to start, I have to recognize that this means I'm taking h of x, so taking that function, minus k of x. What is h of x? H of x is x squared minus 5x plus 7, taking that whole function, and I'm subtracting k of x. K of x is x plus 6. Now, when I'm subtracting, I want to make sure I subtract the whole entire function. So I need to distribute this negative into k of x. Everything in here has to get subtracted. So rewriting this, it's going to be x squared minus 5x. This first parenthesis is just going to stay the same. And then minus x and minus that 6. A lot of times students only subtract the x and they forget to subtract the 6. Now I'm going to combine like terms. Oops. Let me undo that real quick. I didn't mean to write that there. So h minus k of x will end up being, there's only one x squared term, so that'll stay x squared. And then I have minus 5x minus x. Those are my next like terms. I always want to do it in descending order, so highest degree down to lowest degree. Minus 5x minus x would be minus 6x. And then my constants, so 7 minus 6 would be positive 1. And there's the general formula for h minus k of x. Why don't you try the next example? Alright, part C. We're doing g minus h of x, and recognizing that means g of x minus h of x. And the order matters here. You can't flip-flop these two functions because we're subtracting, which is not commutative. So I'm going to take all of g of x, which is 2x squared plus 3x minus 1, and subtract all of h. So x squared minus 5x plus 7. I need to distribute this negative through, so I'm subtracting all of h. Remember, the first parenthesis stays the same. I'm subtracting everything in the second, so all the signs will change. It'll be minus x squared, and then I'm subtracting a negative 5. So those two negatives will make it plus 5x, and then subtracting 7. Now I can combine my like terms and get my final answer, g of h of x will equal, I have an x squared term here, an x squared term there, so 2x squared minus 8, just x squared, will just be 1x squared, or x squared. I have an x term here, and an x term here. 3x plus 5x will give me 8x, and then a constant and a constant. Negative 1 plus a negative 7 would be negative 8. And there's g minus h of x. That's as far as I can go. These next examples are doing division. So division of functions. Again, just doing the general formulas. Part A says p of x divided by h of x. P of x has to go on top. That's 16x to the 5th. And h of x needs to go in the denominator. 24x squared. And then we need to make sure we simplify this as far as possible. So if we can find any common factors, we need to divide those out. So it depends on how you feel comfortable, if you can recognize the greatest common factor, or if you need to just factor it out, such as 16 is 2 times 2 times 2 times 2, and x to the 5th is x times x times x times x times x. If you're a very visual person, you can expand that all the way out. 24 is 8 times 3, and then we have x squared. And you can see all the factors that will divide out. So, for example, 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. And 2 of the x's will divide out. X divided by x will be gone. And then our final answer is everything that's left. I end up with a 2 in the numerator, x times x times x, which is x cubed over 3. So if you have forgotten how to find the greatest common factor, you just expand everything out into prime factors and then divide. If you remember how to do it without expanding it. For example, over here this is 16x to the 5th divided by 24x squared. The GCF there is 8, so you could divide by 8 in the numerator and denominator. 16 divided by 8 is 2, 24 divided by 8 is 3, so that gets us this 2/3. And then the division rule for exponents is you subtract, right? So x to the 5th divided by x squared, we take 5 minus 2, we end up with 3 extra x's in the numerator. So that's the other kind of shorter way to do it. All right, this next example here, we're starting with k in the numerator, 20x to the 6th plus 6, dividing by h of x, which is 24x squared. Now you have to be careful because this one has a plus in here. We can only divide out common factors, not things being added. So we have to look to see if there's any common factors, meaning specifically with these numbers here, I see they can all be divided by 2. What I mean is I could take out a 2 from the numerator, be left with 10x to the 6th plus 3, right? Dividing a 2 out of 20 gives me 10. Dividing 2 out of 6 gives me 3. And dividing out a 2 from that 24 would give me 12x squared. And the 2's would divide out. So I can only divide something out if it divides into every single term when there's a plus or minus in there. So that because of this sum, this plus, I can only divide out common factors that are common to every single term. So my final answer here would end up being 10x to the 6th plus 3 over 12x squared. Now you might ask, couldn't I do more? You know, 10 and 12 have some x's and another factor of 2. 3 and 12 have a 3 in common, but I can't. I can't take out anything else because they don't all have x's. This term here, this constant, does not have an x, so it's not common to every single term. I can't divide out any x's. The 2, 3 doesn't have a 2. It's not common to everything. And the 3, 10 doesn't have a 3. I can only divide out common factors. So it has to go into every single term. And this plus makes a new term that doesn't have those common factors. Try the next example. Part C here. Part C has p of x divided by k of x. P of x is 16x to the 5th divided by k of x, 20x to the 6th plus 6. So again, because of this plus here, I have to look at all three terms. So 16x to the 5th is a term, 20x to the 6th is a term, and 6 itself is a term. So the only thing that I see they all have in common is 2, right? Because 6 doesn't have any x's, and nothing else has a 3 in it besides the 6, and nothing else has a 5 in it besides the 20. So I'm going to go ahead and divide out a common factor of 2 from the numerator and from the denominator. I will end up with, so 16 divided by 2 would be 8. X to the 5th stays the same. 20 divided by 2 is 10. X to the 6th. 6 divided by 2 is 3. And that's as far as I can go. I cannot divide out any x's because this 3 does not have an x.